Hello, Pre-Calc. Sorry I couldn't be in class today. My son is at home sick with the flu, so I'm taking care of him today. I will hopefully be back tomorrow. The goal today is to get a few notes on the things we haven't covered the last couple days. We've been reviewing the trigonometric functions and trying to make sure that we know all the different ins and outs of them. Hopefully this is a review for most of you, but again, the sections I'm pulling this information from out of your textbook is section 4.2 and 4.3, kind of mixing them together. They're starting on page 489, they go through 499. The review of the trig functions is our main purpose here. I want to make sure that we know how to do the trig functions themselves. We'll do a couple examples where we actually find missing values on a picture, on a diagram, using the trig functions. And then the last step is to use the Pythagorean Theorem, which is something that should not be new to you. It's probably the most famous theorem that we have in mathematics. But what we're going to be doing today is showing us on certain examples we don't need to actually use the trig functions. We can actually use the Pythagorean Theorem itself, and it will still help us find a missing value. Now, the other things I want to cover, other than just doing the trig functions themselves and doing the Pythagorean Theorem, is to also work with the inverse functions, not the reciprocal functions like cosecant, secant, and cotangent. I'm talking about the reciprocal or the inverse functions themselves. So that would they're also known as like the arc functions, like arc sine, arc cosine. We'll talk about that as we go. That'll be one of the examples we'll do at the very end, right before the Pythagorean Theorem. But this is our goal. 3 objects. Once we're done with these, then we'll be finished today. You will not be getting homework today. I just want to make sure that we cover a few notes today, and that way when I'm back tomorrow, we can actually talk about what we're going to use these for. So let's jump right in. First example I want to do is use the trig functions to find the height of a tree. Now on this particular object, you can actually see that my angle that I was given is 50 degrees. We are finding the height, and we're given that we are standing 30 meters from the tree, so it's in the metric system. Now, just thinking about this problem out loud, this is a right triangle, right? We have a right angle right here, as you draw out like an imaginary line going through the tree itself. The angle in the top part of the tree, this is 40 degrees. Now, how I know that? The remaining angles in a triangle, a right triangle I should say, these two angles are complementary. They have to add up to be 90. So that's how I can find that missing third angle in a triangle. It's common sense. Triangles have to add up to be 180. But why this is useful, why I would actually want to know that, is because when you have the angles of a triangle, the walls that are across from them, like the wall that is across from 40 or the wall that is across from 50, they're in proportion with each other. Okay, that's how these trig functions work. So the idea here is that the wall that is opposite of 40 would technically be the smallest wall of this triangle, this right triangle. The largest wall would be the hypotenuse, obviously. That is the wall across from 90. And then the medium-sized wall, it's not the smallest but not the biggest, that would be the wall that's opposite of the 50. That's just common sense. So what I can figure out right now, just common sense, is that my height of my tree has to be larger than 30 meters. That's just common sense before you start the problem. You should always think about that, because the bigger the angle, the bigger the wall. Now, I can't just set up a proportion. I can't just set up, the fraction where, you set the actual angle over the wall that's across from it. The reason why these functions, the trig functions, are actually based on a circular path, we'll actually explain that tomorrow. It is not a true proportion the way that you think is a linear function. These are actually curves. We'll actually see that later. We'll actually look at the trig functions and actually draw them. They are actually curves. So, to do these functions, what they are, we have to be thinking about the main trig function, which the main acronym, which is Sohcahtoa. Right? This is the main function or the main little acronym we use to remember what the formulas are. We've been talking about this the last couple days. So when we look at our problem, we are thinking about what our angle is. Obviously, we're given the 50 here, and we want to find the height of the object. So when I have my angle, I want to label the triangle according to the angle that was given. So this is the opposite wall to my angle. I can't write on that. That's odd. It won't let me write anymore. So the opposite wall is the wall across from 50. The adjacent wall is the wall right next to which in our case is the 30, and then we don't actually need the hypotenuse. They're not trying to find the cable going from the ground up to the top of the tree. So in this particular case, I'm finding the opposite wall. So when I'm looking at the trig functions, the one trig function that comes to mind would have to be TOA. The reason being is it's the only trig function that uses O and A in the actual label. So what I want to make sure of here is on this particular problem that we set this up correctly. So if we're using tangent, right, the tangent function of my angle, the O and A actually stand for opposite and adjacent. And so the letters in order from this function make a big difference. So, you know, in the sine over here, this is opposite divided by hypotenuse. In cosine, this is adjacent divided by hypotenuse. So O and A's are big deals. I know my penmanship isn't the best, but hopefully you can see the difference between an O and an A here. So we're going to be setting up tangent. So let's actually plug the numbers in and actually calculate this. So we're going to be doing tangent of 50 degrees is equal to the opposite wall, in our case that's x, that's the height of the tree we're trying to find, over the 30 meters. To solve this, you want to multiply the 30 across. You want to do an inverse function to get the variable by itself. So the inverse function, instead of dividing the x by 30, you want to multiply the 30 to the other side, because what you're actually doing is a property of equality. And when we actually multiply that across, we're taking 30 times the tangent of 50 degrees. That's what we're doing. Now on my iPad here, my actual calculator that I have is non-menu driven. So when I'm actually going to type this in, I actually have to type it backwards. I have to figure out what the tangent of 50 is first, that's a decimal, and then take it times 30. Now the label on my problem will be in meters. So I'm actually going to show you how to type this in. Now on everyone's calculator, most people can just type in exactly how you see it written here. So you can type in 30 tangent 50, hit enter, and it will give you your answer. But on my calculator, you'll get to see that it is menu driven, non-menu driven, I should say. So I'm going to type in the 50 first, then hit the tangent key. The tangent key is right here. So I get 1.19, and then I'm going to take that times 30 meters. And this tells me my answer is 35.75. So if I go back to my picture here, my answer is 35.75 meters. Now, did that make sense? It should. This was going to be my biggest wall of this picture. And it was, so the numbers, in theory, you know, the wall opposite the 40 was 30, the opposite wall of 50 had to be bigger than that, and the numbers are relatively close. 40 and 50 are not very far off in terms of angle measure. So to me, these numbers make sense. And again, it's in terms of meters. So that's how you figure out which trig function to pick and how to actually attempt to solve for a missing variable. So let's do another example here. So the example I have picked out, again, apologies for the terrible picture. This is an airplane. I know that's a terrible picture of an airplane. It's supposed to be an airplane. It's flying in the air. Now, what it's actually doing here, it's flying straight path, and it's the angle that they have labeled here with a 12. That is called an angle of depression. Angle of depression is looking at the horizon and looking down. When you're depressed, you look down, right? So they call that the angle of depression. That angle is the same as the angle of elevation inside the triangle. Now, why? Is because the triangles here that I have, the actual, I should say the lines that I have here, this line and this bottom line, this is the ground. These lines are actually parallel to each other. The horizon and the ground itself is actually parallel. So the angle of depression is actually the same as the angle of elevation, because these angles are called alternate interior. That's something we talked about in geometry. Alternate interior angles are equal. So I can transfer the 12 inside the triangle, which you actually see here, and we can actually solve this. So we're going to try to find, on this problem, we're going to try to find the linear distance on the ground. The ground distance from the spot directly below the airplane to the runway where it's trying to land. So that's the distance we're trying to find. So this linear distance from here to here. That's the letter D that they use. Now again, you can use any variable that you like. They use the D. I'm going to use X on this particular problem. Now the label they have here, it looks like it's in feet. That's a little hash mark there. So we're going to be trying to find the distance on the ground. Now, what I'm expecting before I start the problem, because I always like to kind of guesstimate what my answer is going to be, I'm expecting a pretty large number. The reason being is that the wall opposite the 12 degrees is 4,000 feet. 12 degrees is not a very big angle. In fact, it's quite small. So having the wall opposite of it being 4,000 feet, that is the altitude of my airplane up in the air, that means my angle that's left has to be 78 degrees in the right triangle, because the two angles that are left inside the triangle have to add up to be 90. So, because 12 and 78 add up to be 90. That's a significantly bigger angle than 12. So I'm expecting, the wall, the distance on my right triangle here, the distance that I'm trying to find is going to be pretty long. It's going to be very, very far past 4,000. I'm not going to try to guesstimate what that is, but let's actually do a calculation to actually find it out. So again, you can pick any angle inside the right triangle that you like. I'm going to use the one that they have printed. I'm going to use the 12 here, and we're going to actually solve, and we're going to try to find that distance. So we're going to try to find that. We're going to use the 12 and find the distance on the ground. Now, labeling the walls, this is the opposite wall, and this is the adjacent wall on this right triangle, and then this would be the hypotenuse up here. We're not using the hypotenuse because it's not a number they want us to find, but actually finding the distance. So we're going to set up tangent in this case, because in Sohcahtoa, Toa is the only one that uses opposite and adjacent. So when we're setting this up, this is tangent of my angle, tangent at 12 degrees, is equal to the opposite wall, which is 4,000 feet, over, they use the letter D here. Now to solve this, what we talked about earlier this week is that you could actually just switch the variable with the tangent of 12. It's an inverse operation where you'd actually multiply the variable d across the equal sign, and then you divide by whatever tangent of 12 is. And the tangent of 12 degrees is just a digit, it's a number. So it would actually be dividing it over. So what I have here is d equals 4,000 feet. Now I'm going to change the label here to feet. And we're going to divide by whatever the tangent of 12 is. 12 degrees. Okay, now for my calculator, now most calculators you can just type that in exactly how you see it, but for my calculator I actually have to find out what the tangent of 12 is, because it's a non-menu driven calculator, so I do have to find the tangent of 12, and so I'm going to put that, whatever that decimal is, I'm going to put on the bottom of that fraction, and I know my label will be in feet. Now to type that in my calculator, so I'm going to type in tangent of 12 just to see this. So clear out my calculator, type in 12, and I'm going to hit the tangent key because I have to go backwards. So my decimal here is 0.21255. Now I'm going to round that to 0.21256. I like to go about 4 or 5 decimal places for accuracy purposes. So 0.21256. Let's do that. I think that was the number, right? Yes. Okay, so if we're going to divide these numbers, this should give me in terms of feet. And again, I'm expecting a number to be larger than 4,000. Again, with dividing by a decimal like that, 0.21, you will get an incredibly large number. Dividing by very small decimals, because you're going to be doing a reciprocal, it will give you a large number. So just to prove my point here, let's actually go, not the clock, but let's go back to the calculator. 4,000 divided by 0.21256, 18,818 feet. That's quite a long ways. And again, I was expecting a very large number, and that definitely makes sense to me. So my number here is 18,818 feet. And there's some change after it. But that's feet along the ground. That's linear distance on the ground. A long ways. In terms of mileage, if a mile is about 5,000 feet, 5,280, if we divide by 5,000, about three and some odd miles. So quite a ways. But again, you are almost a mile up in the air. So you do have quite the distance to travel still. Okay. Hopefully that made sense. And again, the vocabulary terms that we used here was angle of depression and angle of elevation. They're the same digit when you actually look in the actual triangles because of the parallel lines. All right, let's move on. Let's take a look at the next types of problems here. So as I was saying before, I want to do a couple of examples where you're finding missing variables, and then we're going to move on to this type of problem where you don't actually need to use the trig functions. You can. I'll show you how to do that here in a second. But on this problem, we're not given any of the angles other than the right angle. So on this problem, we don't need to use the trig functions. In fact, it's almost impossible right now to do that without finding angles on this. So what I'm going to show you is you can just use the Pythagorean Theorem here, and that should hopefully save you a lot of time. The Pythagorean Theorem, if you don't remember from junior high days, this is the Pythagorean Theorem. A squared plus b squared equals c squared. The a, b, and c on this picture stand for, the A and B are the legs of your right triangle. The legs are the two walls that touch the 90-degree marker. And the hypotenuse is the letter C. It is always the longest wall. So that C distance should always be the wall that doesn't touch the 90-degree marker, so the hypotenuse. But again, you're going to take these values and plug it into my function. So my A is an 8 squared, the B is a y squared, and the C is 12 squared on this case. And and it doesn't matter actually where A and B is, as long as they're the two legs. So it didn't matter if you had the y and the 8 switched. But again, we're going to square these, and that's how the formula works. Again, don't just add a plus b equals c. That doesn't work. I'll explain that here in a second. But again, when you plug in these numbers, this is 64 plus y squared equals 144. You're going to subtract the 64 across and get 80. And then we're going to take the square root of 80, because that's the inverse of the power of 2. We're going to take the square root of 80, because again, the power of 2 is actually called a square. So when you take it to the other side of the equal sign, we do the square root. That's the inverse function. Now, going back to my calculator here, I'm going to type in 80 and hit the square root key. In my case, it's right here. So it's 8.9. So 8.94. We want to be a little more exact. So 8.94. And that's my y distance. It's b, 8.94. Okay, now in terms of, common sense, thinking about this number, does it make sense? Yeah, because, the digits on my triangle here are not very large. 12 is going to obviously be the largest side on this triangle. So everything else, single digits in that range. It could have been 10, but, those numbers make sense to me. Now, what I was talking about earlier is when you're doing the Pythagorean Theorem, you have to square the actual variables, so like a squared, b squared, and c squared. The reason why you can't just add a plus b equals c is because it is a triangle path. It's a triangular path. And b, if you were going to tell me that a plus b equals c, a plus b equals c, what you're actually telling me here, if you actually think that works, you're telling me that somebody walking around the block is walking the same distance as the shortcut home. Just a straight path home. That you would add somebody walking around the block and get the same steps as somebody walking straight home. That doesn't work. That's why the Pythagorean Theorem has to have squares in it, so it actually makes the numbers actually work. We can actually go through a proof of that Friday if you'd like to see why it's a squared plus b squared equals c squared. It's kind of lengthy, but again, common sense, you don't just add a plus b equals c. Just because of the triangular path. Now, going back to the numbers here, I said earlier that I was going to show you the trig functions that are involved here. I said that you could potentially do a trig function to find angles, and that could actually help you out here. And what I mean by that is if you want to put a theta in the triangle here, and you can put it anywhere you want, I just put it right there, we can actually find an angle, a missing angle on a triangle. And this is where you could use the inverse trig functions. So let me actually show you how that works here. So how you'd actually do this, again, if you'd label your triangle that where theta is at, this would be the opposite, or this would be the adjacent wall. Sorry, let me erase that. This would be the adjacent wall. This would be the opposite wall, and this would be the hypotenuse. And again, the opposite and adjacent are always legs, and they can switch spots depending on where your angle's at. So if your angle's up here on the top, the opposite and the adjacent would actually switch locations. The hypotenuse would never switch. It's always the longest side. But anyways, what we're going to be doing here is finding the angle itself. So I'm going to use the actual numbers that were printed on the triangle, not that 8.9 number, the decimal that we just found. But I'm going to use the 8 and the 12 that they had printed, and I'm going to try to find the angle there. Now, how I know which trig function to use, again, going back to Sohcahtoa, I'm going to use the Ka formula because that's the one that uses adjacent and hypotenuse. So it's going to be cosine of my missing angle, that's theta, is equal to the adjacent wall, which is 8, and we're going to divide by 12. Now, 8 divided by 12, you can simplify that fraction if you want. Before we start here, dividing them both by 4, I get 2 over 3. So it looks like the cosine of theta is equal to 0.6 repeating, right? So 0.6 repeating over and over and over and over. Okay, so to find the actual angle, this is where we use the inverse trig functions. Now, if you're not familiar with the inverse trig function or the arc functions, it's when you take the cosine and you do the complete inverse. And that inverse function looks like this, where you put a little -1 on the function itself, and you type in the number after it. Now, on most calculators, to find the inverse the actual trig functions like the cosine function here, the inverse, you have to hit the second key or shift key, and then it'll give you the inverse functions. So I'll go back to my calculator here in a minute, but for most calculators, you can just type in exactly how you see there. You have to hit shift, or second, then hit cosine, and then type in your number, and it should show you the little -1. Now again, this, what I've been saying earlier, this is also known as the arc cosine. that is a term that they use in college level math classes, means the same as an inverse cosine. And we only use these keys, the arc cosine or inverse cosine, when you want to find an angle. That's the only time we'd ever use it. It is not the same as doing the reciprocal function, which is the secant of a trig function, which is the secant of an angle. That is not the same as the arc cosine. It is not the same as this. This is the reciprocal. This is an inverse function. They're not the same wording. Okay, reciprocal is when you flip a fraction over. Inverse function when you do the opposite thing to the other side of the equation. So we're not doing the secant. So don't think that they're the same thing. Okay, but again, how to type this in your calculator? I'm going to go back and I'm going to type in the arc cosine of 0.66666. So to type that in on my calculator, I have to type in the decimal first, 0.66666, and I can type as many as I want. Then I have to hit the second key and hit the cosine negative 1. Now, what you're seeing earlier before I hit this, there's a cosine with a little h behind it that is called a hyperbolic function that's used in curves and circular paths. That is not the same as the negative 1 key. So I do have to hit the second key and then hit the cosine negative 1. And it's telling me 48.1 on the screen. That is the actual angle that was involved here. So this angle on my picture is 48.1 degrees. And that's that angle right here, 48.1 degrees. Okay, not bad. If you don't get a number that makes sense to you, maybe you want to double check, maybe you typed in the decimal wrong, maybe you hit the wrong trig function. But again, when you set up your normal trig function, this one, that tells you which inverse you're going to be using. Because again, the inverse functions work for any of the trig. You can do the inverse sine, which is arc sine, or the inverse tangent. So you just have to set up your problem as normal. That's why I labeled the picture. Okay, let's do another one. So I have another picture here. On this particular problem, it's kind of the same thing as before. You could do the trig functions on this particular problem. Now on this one, this would be my A, this would be B, and again, I don't care which one's A or B because they're just the two legs, and this would be C. So again, if you're setting up A squared plus B squared equals C squared, it would be X squared plus 14 squared equals 20 squared, and you could solve. But not every Pythagorean Theorem problem has to have A and B as the missing terms. Like where, I've been using A as my missing term here. It doesn't always have to be that way. In fact, on the next picture I'm going to show you, I'm actually missing on this particular picture, I'm missing the hypotenuse. So if I'm putting the A and B here, here's A, here's B, and here's C, I'm actually missing the hypotenuse. So A squared plus B squared equals C squared. So now I don't need to move things across the equality symbol. I'm just going to square my 6, so that's 36, square 8, which is 64. I'll add those together, which is 100. And then take the square root to the other side, or take the power of 2 to the other side, which is a square root. And we're going to take the square root of 100. Now I know it is positive and negative, but we're talking about in terms of distances, so I'm not using negative numbers. But the square root of 100 is 10. So this actually worked out to be a perfect whole number, natural number, a rational number, but it's not irrational like the last one where I had weird, crazy decimals. So this is 10. And then again, I can find any angle in this picture that I want. Maybe I want to find this angle up here in the top. Well, now I can do a trig function to find that. So if I want to do any of the trig functions, let's say I want to do the opposite wall and the hypotenuse wall. So now I'm doing the sine function, and I can find the angle up there. So the sine of theta is the opposite wall, which in my case is 8, over the hypotenuse wall, which is 10. Now 8 divided by 10 is 0.8 on a calculator. And then you're going to take the inverse sine of that to the other side, so the arc sine. Again, we use this function when we want to find angles. Now, if I go back to my calculator and actually type that in, so 0.8, and then I'm going to hit the second and hit the sine button, so I get 53 degrees. So let me go back here. So that's 53.1 degrees on my calculator, and that would be this angle. And does that number make sense? Yeah, because that was 53 degrees. That means this angle over here is roughly about 30, 37 or 36.9 or something like that. And so the smallest angle will give you the smallest wall, the 6 wall. The medium angle, which is 53, would give me the medium wall, which is 8. And then the 90 degrees would give me the biggest wall, in terms of, thinking about proportion-wise. So that 53 degrees makes sense. And then to find the missing angle, in the corner, I could just subtract it from 90, and I can find this angle down here. But again, hopefully this makes sense to you. The goal today was to show you, the trig function, to refresh your memory on how to do those, to show you the Pythagorean theorem, why we'd choose to do that, because it does help you find, missing values on triangles without having to do the trig functions in certain cases when you're given 2 out of 3 walls. And then to show you the inverse functions. So I've kind of hinted at all week, but we never really talked about when you should use them. That we use those to find angles. Okay, I'll be back tomorrow. We'll continue on with this discussion. We'll have homework tomorrow, so try to bring your textbooks and try to bring a calculator tomorrow, and we'll continue on. Enjoy the rest of your day. I'll see you tomorrow.